Ever get the feeling that, like, maybe the ground beneath our scientific feet is a little shakier than we'd like to think? Like, what if testing a theory isn't like finding a single loose screw, but more like navigating through a maze blindfolded?
Ooh, I like that imagery.
Uh,
Yeah, the idea that certainty might be more elusive than we often assume.
right. And that's a really great segue because on today's deep dive, we're going to wrestle with some ideas from this fascinating figure, Pierre Duhem. Now, he was a French physicist, historian, and philosopher of science, all rolled into one, lived from 1861 to 1916.
A true Renaissance man, right.
Yeah.
And he really made waves in a lot of areas. His work on energetics was groundbreaking. But I think for our audience, what's going to be most fascinating is his thinking on how theories and experiments actually connect.
Yeah. And how messy that connection really is.
Totally. Like his famous Duhem thesis, it still keeps philosophers of science up at night. And then you throw in his work on medieval science, completely upending how we view that whole period.
Yeah.
It's amazing the breadth of this guy.
I know, right? So for this deep dive, I've got the Stanford Encyclopedia of Philosophy entry on Duhem, and I'm really excited to unpack this for our listeners. I think especially for folks who are into like the nitty-gritty of how we know things. Epistemology, Duhem is a gold mine. You ready to jump in?
Absolutely. Let's do it. It's going to be fun, especially thinking about what resonates for someone who's, deeply philosophical. And one thing that really struck me about Duhem is how intertwined all his work is. Like, his history informs his philosophy, and his background in physics shapes both of them. So maybe it's best to start with, like, getting to know the man himself, right? His life and times.
Okay, so Pierre Duhem, born in Paris in 1861. Now, his family background is interesting. His dad was kind of forced into the textile industry, but was this huge bookworm at heart. And his mom came from a pretty bourgeois Parisian family, so you can imagine there was a lot of emphasis on learning in that household.
Oh, yeah, definitely. And you can't underestimate the impact of those early years.
Yeah.
Right? He actually lived through some pretty turbulent times. Like, imagine being a young boy and witnessing the Franco-Prussian War and the Paris Commune.
Wow, yeah, that must have been really formative.
It really shaped him, especially the strong anti-religious sentiment during the Commune. He became very conservative, deeply Catholic, and that comes through in all his work, even his scientific work. It's like this thread throughout his life.
Yeah. It's wild how much your personal experiences, even as a kid, can shape your whole worldview. Okay, so education-wise, he had private tutors, then went to this Catholic school, College Stanislas, for like 10 years. And his science teacher there, Jules Moutier, seems like he was a pretty big deal for Duhem.
Oh, absolutely. Duhem himself said that Moutier basically ignited his love for physics, instilled in him this desire to really contribute to the field. And what's interesting is Moutier was a theorist himself, came up with some key ideas in thermodynamics, even anticipated some of the work of Gibbs, who was a huge influence on Duhem later.
So, clearly, a bright kid. Goes from Catholic school straight to the top science school in France, the École Normale Supérieure, graduates first in his class. Talk about a promising start. But then, his doctoral thesis hits a snag. What happened there?
Yeah, this is where things get messy, and you start to see how science, politics, and personality all get tangled up. His thesis was on thermodynamic potential, and it actually challenged some of the core ideas of this very powerful guy in French science, Marcelin Berthelot, who was like tight with the people on the thesis committee.
Uh-oh, sounds like trouble.
It was. You see, Berthelot had this principle that was super popular at the time, basically said that spontaneous chemical reactions tend to release the most heat. And Duhem's work was like, nope, not always the case. So Berthelot, being who he was, supposedly declared that Duhem would never teach in Paris. And guess what? That's exactly what happened.
Wow, talk about holding a grudge.
Right. I mean, whether that's the whole story or not, Duhem ends up spending his whole career in provincial universities. Lille-Rennes, finally Bordeaux, not exactly the center of the scientific universe back then. And on top of that, he also suffers this horrible personal tragedy, loses his wife and newborn baby.
Oh, man, that's heartbreaking.
Yeah, it really was. He never remarried, raised his daughter Helene with the help of his mother. But despite all that, professionally, personally, the guy just kept going. His publication list is mind-blowing. Over 350 publications, like 50 books. Incredible.
Talk about resilience. That brings us to like the real meat of our deep dive, his philosophy of science. And we got to talk about the Duhem thesis, right? But before that, the entry mentions he started as a positivist and then shifted his views. What was that all about?
Okay, so early Duhem, he was all about positivism, thought of physical theories as just like tools to organize facts, symbolic systems. And he kept science totally separate from metaphysics, like those were two different worlds.
But then something changed.
Right. He got this critique from this Catholic engineer, Eugene Vicaire, who basically said, hey, if you divorce physics from metaphysics completely, you're basically surrendering to skepticism. And that got Duhem thinking.
So Vicaire was like, hold on, there's got to be some connection between how the world actually is and how we understand it through physics, right?
Exactly. And this is where Duhem's Catholic background comes in. He starts leaning towards a more Thomistic view, seeing metaphysics as a real, even higher form of knowledge, but still distinct from physics, like they have different objects and methods.
So he's not saying science is just making stuff up, but that there's a deeper reality that science is trying to grasp.
Right. And this shift, it's actually part of a bigger trend in Catholic thought at the time, Neo-Thomism. But Duhem's mature philosophy goes beyond that. This is where his ideas about underdetermination, his skepticism of models, and his concept of natural classification come in. Each one is super interesting in its own right.
Okay, let's dive into the Duhem thesis. This one's a biggie for any philosophy student,
Right.
right? What's the core idea here, in a nutshell?
Okay, so imagine you're testing a scientific hypothesis, right? Duhem's point is you're never testing it in complete isolation. There's always this whole web of other theories, assumptions, background knowledge, all tangled up in how you design the experiment, how you interpret the results. It's not a simple if A, then B situation.
So it's more like if A and C and D, and we assume E and F, then maybe B, but maybe not.
Exactly. And this is where his famous quote comes in. If the predicted phenomena is not produced, not only is the question proposition put into doubt, but also the whole theoretical scaffolding used by the physicist.
Whoa, okay, so one failed experiment could potentially unravel a lot more than you think.
It could. And that's what he called the non-separability thesis. You can't just test one isolated hypothesis. It's always part of this larger system. So when things go wrong, it's not always obvious where the error lies. Could be the main hypothesis, could be an auxiliary assumption, maybe your instruments are wonky, who knows?
Makes you realize how much faith we put in those instruments.
You're right. Totally. And Duhem points out that there are different ways to react to these experimental hiccups. You've got your timid scientist who tries to tweak the existing theory, add more bits and pieces to make it fit the data. Then you've got your bolder scientist who might say, okay, maybe we need to rethink some of our core assumptions here.
So like a paradigm shift kind of thing.
It could be, yeah. But Duhem's point is, both approaches can be logically valid. There's no single right way to respond to a failed prediction. And this is where he challenges the Newtonian method, the classic idea of making observations, coming up with general laws, and then testing those laws through more observations.
So he's questioning the whole inductive approach.
In a way, yeah. He argues that this Newtonian method, it works great when you're dealing with stuff you could directly observe. But as science gets more complex, starts relying on these super intricate instruments and measurements that themselves depend on complicated theories, well, that simple inductive picture breaks down.
I mean, it makes sense. Like, how do you even observe an electron directly? You need a whole theory just to interpret the readings from your instruments.
Right. And this is where Duhem's work really foreshadows some later stuff, like the Duhem-Quine thesis. You familiar with that one?
Oh, yeah. Quine takes this idea of the interconnectedness of beliefs and runs with it, right? Like, basically says you can hold on to any belief if you're willing to adjust enough other beliefs.
Exactly. But it's important to note that Duhem himself wasn't as radical as Quine. He was more focused on the ambiguity of what gets disconfirmed when an experiment goes wrong, not necessarily the ability to cling to any belief no matter what. And it was also careful about extending this idea beyond physics, which some folks were doing, like those pragmatist thinkers.
Like applying it to history or religion.
Yeah, exactly.
Yeah.
Duhem thought physics was kind of special because of its heavy reliance on math and these precisely calibrated instruments. Other fields, not so much.
So he's acknowledging the limits of his own thesis. Okay, let's move on to another big part of his philosophy. His critique of the Cartesian method and his views on metaphysics and models. He really wasn't a fan of mechanistic explanations, was he?
Not at all. He was very much a proponent of what was called energetics back then. So you've got your Cartesians and Newtonians trying to explain everything in terms of these tiny invisible particles and their motions.
Right, like atoms and stuff.
Exactly. But Duhem, he saw that as kind of a dead end. He preferred energetics because it focused on the relationships between measurable quantities like energy, temperature, pressure, without speculating about the underlying mechanisms.
So it's more about describing what you can actually see and measure, rather than making up stories about what might be happening at a level you can't see.
Precisely. He thought mechanistic theories were ultimately dependent on metaphysics. on assumptions about the fundamental nature of matter, which could change with the philosophical winds. And that made physics vulnerable to all the uncertainty and instability of metaphysics.
So energetics was like a safer bet, sticking to the observable, the empirical.
Exactly. And this is where his beef with James Clerk Maxwell comes in. Maxwell, the electromagnetism guy.
Oh, yeah, Maxwell's equations, right.
Yeah. Well, Duhem saw Maxwell as the poster child for what he called the Cartesian method.
Yeah.
He had a few major criticisms. First, he thought Maxwell was way too quick to introduce new concepts, like those displacement currents.
Like adding bells and whistles to the theory before it was really necessary.
Exactly. Duhem thought you should exhaust the explanatory power of your existing concepts before adding new ones. And second, he really went after Maxwell's use of models, both mechanical and even mathematical ones.
Now, this is interesting, right? Because models are so central to how we do science today.
They are. But Duhem saw this as a sign of what he called the English mind, this tendency to think that building a model is the same as understanding something. He thought it blurred the line between representation and explanation. Like, a model can help you visualize something, but it doesn't necessarily tell you why it works that way.
So for Duhem, a true explanation needs to go deeper to connect with those fundamental principles.
Right. And he also thought that models, especially those fancy mathematical ones, they kind of break the historical continuity of science.
Huh, that's a new one. How so?
Well, for Duhem, understanding the history of a scientific idea was super important. He thought a good theory should build on what came before, be part of this continuous tradition. But models, they often introduce these completely new ways of thinking, which can obscure the historical roots.
So for Duhem, it's not just about getting the right answer, it's about understanding how we got there.
Exactly. And this connects to another one of his big ideas, the concept of natural classification. You see, Duhem believed that the ultimate goal of physics is to arrive at this perfect system of laws that reflects the true essence of material things, a kind of ultimate metaphysical explanation.
Like grand unified theory of everything.
Sort of, but more than that. It's about finding a classification system that's not just convenient, but actually mirrors the way reality is structured. And he thought the value of any scientific theory should be judged by how much it contributes to this long-term goal.
So it's not just about predicting things accurately, it's about revealing something deeper about the universe.
Exactly. And this is where things get tricky for interpreting Duhem. Because on the one hand, he's super skeptical of metaphysical explanations within physics, but then he's got this idea of this ultimate natural classification that sounds kind of metaphysical itself.
It's like he's walking this tightrope between empiricism and realism.
Right. And scholars are still debating whether he leans more towards one side or the other. But regardless, it's a really fascinating tension in his thought. Now, the entry also mentions some of his later work, where he starts talking about different scientific minds, and this is where things get a little controversial.
Yeah, like, is he about to get into some national stereotypes here?
Kind of, but it's more complicated than that. He talks about the English mind, esprit de finesse, which is all about concrete details, practical solutions, ad hoc explanations. Then there's the French mind, esprit de géométrie, which loves abstract theories, elegance, simplicity. And later he adds the German mind, which he sees as too focused on logic, lacking what he calls bon sens, like good judgment rooted in a deep historical understanding.
So there's like three different ways of approaching science.
Exactly. And he insists that these aren't just national stereotypes. Like, he actually uses Napoleon as an example of the English mind, even though he was French, and Newton as an example of the French mind, even though he was English.
Yeah, okay, so he's not just saying the French are good at math and the English are good at tinkering.
No, it's more about different intellectual styles, different ways of thinking about problems. And he actually saw German science as a kind of degenerate form of French science because it was too heavy on logic and not enough on that bon sens.
So for Duhem, the ideal scientist is someone who can balance those different approaches.
Right. He even talks about a continuum of scientific styles, with German logicism on one end, English model building on the other, and French science somewhere in the middle.
Interesting. So where does his critique of crucial experiments fit into all of this?
It's all connected, right? He argued that crucial experiments, these experiments that are supposed to definitively decide between two competing theories, well, they're kind of a myth. Because remember, hypotheses never exist in isolation. There are always those background assumptions, those auxiliary hypotheses lurking in the shadows. So even when an experiment seems to contradict one theory, there are always other ways to interpret the result, maybe tweak the theory a bit, or even come up with a whole new theory.
So like that classic example of the wave theory of light versus the particle theory.
Exactly. You've got Foucault's experiment where he measures the speed of light in water, and it seems to totally disprove the particle theory.
But Duhem points out that there are always other possibilities, like Maxwell's electromagnetic theory, which could account for the result without completely rejecting the particle idea. So even in science, things are rarely black and white.
Right. And this is why the Duhem thesis is still so relevant today. It forces us to be more nuanced in how we think about theory choice, about what it really means for an experiment to confirm or disconfirm a hypothesis.
And it makes the job of a scientist a lot harder, right?
Definitely, because now you've got this problem of isolating defective hypotheses. Like when something goes wrong, where do you even start looking for the error? Duhem's own solution, bon sense, well, it's kind of vague, right?
Like, just use your gut feeling.
Yeah, and philosophers haven't been too impressed with that as a rigorous methodology. But other folks have come up with more sophisticated approaches, like inference to the best explanation, Bayesianism, all trying to grapple with this challenge that Duhem so brilliantly articulated.
So his work is still shaping how we think about the very foundations of science, even today.
Absolutely. It's a testament to how profound his insights were. Now, we've talked a lot about his philosophy, but we can't forget his other major contribution, his work on the history of science, especially medieval science. And this is where he really flips the script on a lot of the assumptions of his time.
Yeah, he basically revolutionized how we view the Middle Ages. Back in the 19th century, the common view was that the Middle Ages were like this scientific wasteland, a midday slumber, as we shall put it. And even Duhem himself bought into that idea at first. But then something happened.
What was it?
He was doing research on the origins of statics, and he stumbles upon this reference to this medieval thinker, Jordanus Namor, a guy who was basically forgotten at the time. And this sparks a whole new passion in Duhem. He starts digging into medieval science, and what he finds blows his mind.
So he's like an archaeologist of ideas, uncovering this lost world.
Exactly. And what he discovers is that there's actually a lot more continuity between medieval and early modern science than anyone had realized. He starts challenging this narrative of the scientific revolution as this sudden break from the past.
So, like, he's saying those Renaissance geniuses weren't building from scratch.
Right. He argues that many of the key ideas, the concepts we associate with Galileo, Copernicus, they actually had roots in the work of medieval scholars. Like one example is the theory of impetus, which is kind of a precursor to our modern concept of inertia.
So the idea that an object in motion tends to stay in motion.
Exactly. And Duhem traces this idea all the way back to John Philoponus in the 6th century, then through Islamic thinkers, then to guys like Buridan and Oresme in the 14th century, and then to Galileo, Descartes, Leibniz.
So it's this long, winding intellectual journey.
Exactly. And he even finds instances where Galileo is using almost the exact same arguments as Buridan, a 14th century Parisian scholar. Like, wow, maybe Galileo wasn't quite as original as we thought.
That's amazing. It's like tracing the family tree of a scientific idea.
Right. And Duhem even suggests how these ideas might have been transmitted, talks about guys like Albert of Saxony, whose works were widely printed and available, and how they could have influenced later thinkers like Galileo, who explicitly refers to the Doctors Parisienses, which is basically a shorthand for Buridan and his crew.
So he's not just saying, hey, these ideas existed in the Middle Ages, but he's actually trying to map out how they influenced later scientific developments.
Exactly. And this all culminates in his magnum opus on the history of science, Le Système du Monde. It was supposed to be this 12-volume epic tracing the history of cosmological ideas from Plato to Copernicus. Sadly, he didn't finish it before he died, but the 9 volumes he did complete are like this incredible treasure trove of medieval science.
So what's in those 9 volumes?
It's everything, man. Medieval astronomy, astrology, tidal theory, even stuff like the concept of infinity, the plurality of worlds. He digs into these obscure primary sources, brings them to light for modern scholars. It's a monumental work of scholarship.
So how did people react to this? Did it immediately change how historians viewed medieval science?
Not really. Like, at first, there's a lot of resistance. This big Galileo scholar, Antonio Favaro, he straight up rejected Duhem's whole continuity thesis. And even later historians like Alexandre Koyré, who's considered one of the founders of the history of science as a field, he had some serious criticisms of Duhem. Like, What?
Well, Corey was all about the importance of metaphysical shifts in driving scientific revolutions. He thought Duhem was downplaying those big breaks with the past, and he also disagreed with some of Duhem's specific historical claims, like his dating of the birth of modern science.
So even though Duhem opened up this whole new field of study, his interpretations weren't set in stone.
Exactly. But despite those criticisms, Duhem's work had a huge impact. I mean, he basically put medieval science on the map as a legitimate area of historical inquiry. And his emphasis on the continuity of ideas, well, that's influenced a lot of later scholars, even if they disagree with some of his specific interpretations.
So he forced historians to take the Middle Ages seriously as a period of intellectual ferment, not just a dark age.
Totally. And I think that's a really important takeaway for anyone studying the history of ideas, like progress is rarely linear, and those seemingly sudden revolutions often have much deeper roots than we might think.
So as we wrap up our deep dive into Duhem, what are the big lessons here for our listeners, especially those who are into philosophy, right?
I think there are a lot of gems here. First, Duhem really challenges this simplistic idea of science marching forward in a straight line. He shows how messy it really is, how theories, experiments, historical context, even philosophical and religious beliefs, they're all tangled up together. It's not as clean and objective as we sometimes imagine.
Yeah, like science is a human endeavor with all the messiness that entails.
Exactly. And the Duhem thesis, that's a real mind bender for anyone thinking about how we justify our beliefs. Because if it's true that we can never test a hypothesis in isolation, then what does it even mean to say that an experiment confirms or disconfirms a theory?
Yeah, it's like this deep skepticism about our ability to pinpoint the truth.
Right. And then there's his historical work, which shows that even our most cherished scientific ideas often have a much longer and more complicated history than we realize. And that's a lesson that applies to philosophy too, right?
Yeah.
Those ideas we grapple with today, they've been shaped by centuries of debate and refinement.
It's like standing on the shoulders of giants, except sometimes you realize those giants were standing on the shoulders of other giants and so on, all the way back.
Exactly. So for our listeners who are deep into philosophy, I think Duham's work offers a lot of food for thought. Like, how might his ideas about underdetermination or historical continuity apply to the philosophical debates you're interested in? Does his concept of a natural classification, this ultimate goal of finding a system of laws that reflects the true structure of reality, does that resonate with you?
It's a big question, right? And I think engaging with Duham's work, even if you don't agree with everything he says, it forces you to think more deeply about the nature of knowledge, about the limits of our understanding. And that's always a good thing, right?
Totally. So yeah, we encourage everyone to take their own deep dive into Duham's work. It's a challenging but rewarding journey, and it might just change the way you think about the world. And with that, we'll leave you to ponder those big questions. Until next time on The Deep Dive.
Yeah.